A ring of mass M is threaded on a smooth circular wire of centre C. Okay, shh. So the ring is threaded on it, which is fixed in a spherical position. The ring is projected horizontally with initial speed u, and from the lowest point on the wire. Show that the ring will just reach the uppermost point on the wire if u equals 4 square root of 4GA. Find the magnitude of the direction at the wire when the line CK makes an angle 60 degrees with the downward vertical from C. Okie dokie. So, we have here is a circle. We also have is that the what's it, reaction force R more than likely. So it's a ring down here, isn't it? Ring K is threaded on a smooth circular wire, center C of radius A, which is fixed vertical position. The ring is projected horizontally at speed u. And then from the lowest point of the wire, show that the ring will just reach the uppermost point. So we're saying it's going from here, it's going to go from this position here to this position at the end. So it's going to be the end, and this is going to be the start. Now, in the language it says just reach. What does just reach mean? It gets there with nothing to spare. It means your final velocity at the very top is going to be 0. Okay, so there's nothing to work with. There's nothing left to work with by the end. Okay, so the ring is going to, as I said, the ring is going to move its way up and around, and then come all the way back up again. Okay, so how to resolve the forces. Now, I'm looking at the wrong one, that's what I'm confused. There we go. Now, that's more like it. Now, what we do is we're going to take a standard position. We're going to say that the ring is here. At one point in time, the ring will go by this position, and we're going to resolve the forces in this position. So we'll have a down and up. Okay. You could also, in theory, you could also take this as your standard position and resolve it this way as well, and you'll get a similar answer. The position of the ring is arbitrary when you're just setting up your equations. It doesn't really matter. Okay. So we'll just work with the downward one starting off. Okay. So let's make up a random angle. Call this theta. Okay. Can anybody tell me where the R value is? Where is the R value going to go? It's going to go up by the radius, or in that direction there. Okay. We call that angle theta. Okay. What about the weight of the ring? The weight of the ring? Straight down. Okay. Now, what we have to do is we can also find out the length of the radius. What's what we call the radius? We'll call it R. Might as well. So the radius length is small r. Everybody happy with that? Radius length being small r. What can you tell me about its height above the ground from here to here at the moment? Okay, so if this is technically a length of small r, that makes that a length of r cos theta. R cos theta being this little length in here. Therefore, the length between the two green dots, r minus r cos theta. Everybody happy enough with that? Will I go over again? We're good. Okay, so that's r minus r cos theta is your height. Remember, in vertical motion, what are the two formulas you're looking at? You're looking at Fc equals what's it, mv squared over r. And your second equation, guys, can anybody tell me what the second equation you use is? K1 plus P1 equals Ke2 plus Pe2. Otherwise known as what, guys? Conservation of energy. Your kinetic energy formula is a half mv squared. Your potential energy is mgh. Okay. So at the start, do you have any potential energy at the start? You don't, because you're at the bottom of the ring. You have no gravity, you have no height above the ground, you have no energy saved up. So it's going to be a half mu squared. Do we have any potential energy? Zero potential energy. Zero. Now, at this arbitrary point here, what can we say it is? Excuse me, I'm proving that when we reach the top. So when we reach the top, what is our speed at the very top? V equals 0. So no kinetic energy at the end of the question. And then how high are we above ground? We have R here, and we have another R there. So we're 2R above the ground. Okay? So mg2R. A half mu squared equals, what's it, 4 mgr? Oh, sorry, 2 mgr. Okay. Mu squared will therefore be 4 mgr. We okay with that? Now, it specifies that the radius is, it's radius A, doesn't it? The radius is A. So when it specifies that the radius is A, we can change that to 4, the m's will cancel. So it's 4ga equals u squared. And then we're asked, both sides, u equals the square root of 4ga. Is that alright? Yeah.
Where are you getting the A from?
It specifies that the radius of the circle, I call it R. It says in the question, A is the radius. Okay? So, that's it there. That's our energy, conservation of energy equation used up. Now go back. Find the magnitude and direction of the wire when CK makes an angle 60 degrees with the downward vertical. What does 60 degrees to the downward vertical mean, guys? 60 degrees to the downward vertical? Anybody tell me? No? Okay. So 60 degrees. Alright. I need to set up my system. I suppose I can set it up two ways, alright? I'll show you. Downward vertical is technically here, isn't it? Would you agree with that? 60 degrees to downward vertical is technically this angle here. Yeah? Everybody see that? 60 degrees to the downward vertical. Oh, sorry, is it the upward vertical or downward vertical? 60 degrees to downward vertical. Oh, sorry. There. Downward vertical is this one here. That one there is meant to be 60 degrees, okay? So upward vertical would be that 60 degrees to the upward vertical. The downward vertical is this theta equals 60 degrees. Excuse me. Okay? I'm going to set up my system. I haven't gone near the FC formula yet. I haven't gone near that yet. Okay? So FC equals mv squared over r. Now, mv squared over r, guys. Okay? What can we have to resolve our weight going in the direction of the radius. So that's theta. That's 90 minus theta. And what am I looking for here? rub this out for a second. Theta, 90 minus theta. And this here will be, trying to figure out this angle here. Isn't it? There we go. Alternate angle being theta makes that angle there theta. Okay? Do you want me to go over that again, or we good? It's just alternate angle. You can see it clear as day here. This is basically where I got my theta from. Alternate angle there, and then opposite angle to find it in there. Now, what happens is this mg, the mg is here. What does that make this component here? Mg sine theta or mg cos theta? Mg cos theta. This component here, mg sine theta. Now, I had to find the forces, the centripetal force, so I had to find the forces that go into it. Okay, so what forces go towards the centre of the circle? Remember the particles here, so what forces go towards the centre of the circle? Mg cos theta is going away from the centre of the circle. What goes towards the centre of the circle? R. Capital R going towards the centre of the circle. Your mg cos theta gone away from the centre of the circle. That will give me mv squared. What's r in this question? A. mv squared over. Okay. Equation 2 is the conservation of energy again. Just going to come back over here and reuse this here. Now, at the start of the question, we still have no energy at the start of the question, don't we? Because we start at the bottom. The bottom has no potential energy because it's not elevated above ground. Our speed, let's see what they did here, right? Our speed is a half mu squared. Find the reaction, magnitude direction of the wire when CK makes lines, CKs with the downward variable if U. It tells us the U value. Everybody got that? U value is in play. So the U, if U is 4GA, U squared is 4GA. So the 4GA is in play. So we have M times 4GA. Potential energy is still 0. Our kinetic energy at a random point. Our kinetic energy at this random point here is V. Okay, why is it not 0? Because it's not at the very top. We're talking about a random point on your path. You're not near the top yet, so your speed is just V. Okay, so it's a half mv squared. Now your potential energy at this point. This is what we worked out earlier on. Anybody remember? What did we work out earlier on? Remember the difference between the two green dots? Somebody gave it to me earlier on. If this is your, if that's your angle theta, the radius of the circle is A. The radius of the circle is A. What does that make this red line here? A cos theta. What does that make the difference between these two yellow points? Yeah, it's R, but A is R, so it's A minus A cos theta. Okay, so it's mg h, which is A minus A cos theta. So I have to do a wee bit of multiplication to be doing here. So I'm going to get a 2 mga plus 0. Going to have a half mv squared, and then I'm going to have mga minus mga cos theta. Move everything to one side. I'm going to get a mga plus mga cos theta equals a half mv squared. Multiply it by 2. Mv squared ends up to be 2 mga plus 2 mga cos theta. Okay, look at the similarities between the two equations now. In one equation I have mv squared isolated on its own, and in the other equation I have mv squared over a isolated. So you can do two things. I suppose I could divide both sides by a. That might make things really easy, wouldn't it? So if I divide both sides by a, I'll get mv squared over a. I'll put a underneath here and a underneath here. Those a's will cancel. Okay, so what I'll be left with is, and then just get rid of that, and now we have two compatible equations. So now what I can say next is that, what can I say? I can say 2mg plus 2mg cos theta equals r minus mg cos theta. Bring it over to your side. 2mg plus 3mg cos theta equals r. Now what does it say about theta? Theta equals 60 degrees. Therefore cos theta will equal a half. So 2mg was it plus 3 over 2? And r equals 7 over 2 mg. That's perfect. Okay, it's one of them done.